I will begin today's video talking about exponents. I am going to give you just a brief explanation of exponents because we will use them in the problems I will show you today. This is a number with an exponent. This small number 4 is the exponent. We call this number 5 to the power of 4. The exponent of a number stands for the number of times the number is multiplied by itself to get the value of the number. For example, 5 to the power of 4 equals 5 times 5 times 5 times 5, which equals 625. 4 to the third power equals 4 times 4 times 4, which equals 64. If the exponent of a number is a 2, instead of calling it 5 to the power of 2, we often call it 5 squared. If the exponent is a 3, instead of calling it 4 to the power of 3, we often call it 4 cubed. We will now go over the rules or laws of exponents. Multiplying exponents. In algebra, a dot often represents the multiplication sign. The reason for this is because in algebra, the letter x, known as a variable, is used to represent an unknown number, and the normal multiplication sign x may get confused with the variable x. When you multiply exponents, as long as the bases are the same, in this case the base is y, you add the exponents. Y to the 4th power times y to the 4th power equals y to the 8th power. Here's an example. 6 to the 2nd power times 6 to the negative 4th power. The bases are the same, they are both 6, so we add the exponents, 2 plus negative 4, and we get 6 to the negative 2nd power. Try this next one on your own. When multiplying exponents, you add the exponents. 4 to the 8th power times 4 to the 4th power equals 4 to the 12th power. When dividing exponents, instead of adding, you subtract the exponents. X to the 8th power over x to the 3rd power equals x to the 5th power because 8 minus 3 equals 5. Using real numbers, 6 to the 9th power over 6 to the 3rd power equals 6 to the 6th power. Try this next one on your own. Again, when you're dividing exponents, you subtract the bottom exponent from the top exponent. So 7 to the 10th power over 7 to the 5th power equals 7 to the 5th power. This next one is called raising an exponent to a power. If you have an exponent inside of parentheses with an exponent on the outside, you multiply the exponents. So x squared to the second power equals x to the 4th power. With real numbers, that would be 7 squared to the 4th power equals 7 to the 8th power. Try this next one on your own. Raising an exponent to a power, you multiply the exponents. If you have 9 to the 3rd power in parentheses, and all of that is to the 2nd power, you multiply the exponents, and 3 times 2 equals 6, so it's 9 to the 6th power. In this case, we have two different variables inside of parentheses. They're being multiplied, and we have an exponent outside of the parentheses. So in this case, we rewrite with both variables having the exponent. So x times y to the 4th power would equal x to the 4th power times y to the 4th power. Using real numbers, we have 4 times 10 to the 12th power. We rewrite it as 4 to the 12th power times 10 to the 12th power. Try this next one on your own. In this case, we rewrite it with each number having the exponent. 7 times 5 to the 5th power equals 7 to the 5th power times 5 to the 5th power. In this one, we have a fraction with two different variables, x over y, inside of parentheses with an exponent on the outside. In this case, we rewrite the fraction with both variables having the exponent. So x over y to the 8th power equals x to the 8th power over y to the 8th power. Using real numbers, that would be 5 over 10 to the 8th power would be 5 to the 8th power over 10 to the 8th power. Try this next one on your own. In this one, we need to rewrite the fraction with both numbers having the exponent. 3 over 4 to the 7th power equals 3 to the 7th power over 4 to the 7th power. In this case, I have a variable x to a negative power. Whenever you have a variable to a negative power, you can write it as a fraction with 1 as the numerator over the variable or number, changing the exponent into a positive one. So in this case, I have x to the negative 4th power equals 1 over x to the positive 4th power. Using real numbers, I have 10 to the negative 3rd power. I can rewrite it as 1 over 10 to the positive 3rd power. Try this next one on your own. When we have a negative exponent, we rewrite it as a fraction with 1 as the numerator, and in this case over 5, changing the exponent into a positive one. In this case, the negative 2 becomes a positive 2. Any number to the 0 power equals 1. So x to the 0 power equals 1. And here's another example, 7 to the 0 power equals 1. Try this next one on your own. Because any number to the 0 power equals 1, 9 to the 0 power equals 1. Now I'm going to introduce you to scientific notation. Scientific notation is a way of writing very large numbers or very small numbers in a shortened form. Like I said before, scientific notation is a way to write very large numbers or very small numbers in a shortened form. In this case, we have 33 million, and I want to change it into scientific notation. What I do is, whenever you have a whole number, then you assume there is a decimal point at the end. We want to go from the end until we get all the way up to the place between the first and second number. So I'm going to move it 1, 2, 3, 4, 5, 6, 7. And I'm going to put my decimal point here. Now, I take my actual numbers that are not 0, which in this case it's 3.3, and I multiply it by 10 to the 7th power because we moved the decimal point 7 spaces to the left. And this is scientific notation, 3.3 times 10 to the 7th power. Here I have a very small number, 0.000036. In this case, I'm going to move my decimal point to the right, and I'm going to move it just past the first non-zero number. 1, 2, 3, 4, 5, 6. So again, I write my non-zero numbers. I have 3.6, and this time I multiply it by 10 to the power of -6 because I moved my decimal point 6 spaces to the right. If you're moving it to the left, it will be 10 to a positive power. If you're moving it to the right, it will be 10 to a negative power. Let's try it the other way. This time I'm going to change from scientific notation into standard form. So here I have 5.5 times 10 to the 2nd power. So let me write my 5.5. Now, since it's 10 to the 2nd power, I want to move my decimal point 2 places to the right. Now, I have to put in a 0, and my decimal point goes right there. So 5.5 times 10 to the power of 2 equals 550. So basically, we're just doing the opposite of what we did before. Let's try one with a negative power. I have 4.7 times 10 to the -5th power. So I write down my 4.7. And because the 10 is to a negative power, I know that my number is going to be a decimal. So to create a decimal, I'm going to move my decimal point to the left, and I'm going to move it 5 spaces. 1, 2, 3, 4, 5. I'm going to put it here. I'm going to put zeros in for all those spaces that I moved the decimal. And 4.7 times 10 to the -5th power is 0.000047. Therefore, it is a decimal. Just to clarify, to make sure that you understand what I'm doing, I want to do all 4 types of problems on one page so you can see which way you move your decimal point. We're going to start by changing 15,000 into scientific notation. The decimal point is at the end, and we want to move it over to the left until we get just past the first number. 1, 2, 3, 4 spaces. So I'm going to put my decimal point between the 1 and the 5. All right, now I have, to write it, I have 1.5, I write down the non-zero numbers, times 10 to whatever power that I moved the decimal point. In this case, I moved it 4 spaces, so it's 1.5 times 10 to the 4th power. So whenever we have a whole number like this, it's going to be written in a positive power of 10. This time I have 0.0015, so I have a decimal. In this case, I'm going to move my decimal point in the opposite direction, so I'm going to move it to the right, and I'm going to move it until I get just past the first non-zero number. So I'm going to move it 1, 2, 3, 4. So I'm going to put my decimal point right there. And this time I write my non-zero numbers, so it's 1.5. But since I am using a decimal number, I am converting a decimal number into scientific notation. This time it's going to be times 10 to a negative power. And it is going to be 10 to the negative 4th power because I moved the decimal point 4 spaces to the right. Now we have scientific notation that I want to change into standard form. So I have 14 times 10 to the 3rd power. All right, I begin by writing my number 14, and my decimal point would be here at the end. I'm going to move that 3 spaces to the right because it is a positive power. I know that this is going to be a whole number and not a decimal. So I'm going to put zeros in place of the spaces which I moved. So in this case, I end up with 14 times 10 to the 3rd power equals 14,000. Finally, I have 14 times 10 to the negative 3rd power. Since it's a negative exponent, I know that it's going to be a decimal. So I write my 14 starting at the end. I move 1, 2, 3 spaces. I put my decimal point there. I put in my 0. And I have 14 times 10 to the negative 3rd power equals 0.014. So you can see if it is a negative power, it's going to be a decimal number. And if it's a decimal number, if you're changing it into scientific notation, it's going to be to a negative power. If it is a positive exponent, then you're going to be dealing with whole numbers such as 15,000 or 14,000. Try this next one on your own. Okay, we start at the end and we count over 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 6.62 times 10 to the 8th power. Even though we have three numbers here, 6, 6, and 2, you still move the decimal point over between the first and the second number. Try this next one on your own. We start at the end and we count over 1, 2, 3, and our answer is 7.7 times 10 to the 3rd power. Try this next one on your own. Because we have a negative exponent on this, I will start by writing down the 7.7, and because it's a negative exponent, I know it's going to be a decimal. So I will be moving my decimal point to the left. And in this case, I'm going to move it 7 spaces. 1, 2, 3, 4, 5, 6, 7. I put zeros in for all of those spaces. And there we have it. So 7 times 7 times 10 to the negative 7th power is 0.00000077. So that is 6 zeros and then 2 sevens. Try this next one on your own. All right, this time I need to move the decimal point 2 spaces, so it will be 660. Try this next one on your own. If I move my decimal point over 6 spaces, I'll put my 2 fours down. Now if I move it past that 4, that's 1 space, and now I need to add 5 zeros. And if I put my commas in there, then I have, let's see, that is 4,400,000. Try this next one on your own. This time I need to move my decimal point 3 spaces to the right. All right, that would be 1, and I add my 2 zeros, which will make it 3 spaces. And I have 8,800. Try this next one on your own. This time I'm going to move the decimal point 6 spaces to the right. If I put down my 8, that's 1 space. And I need to add 5 zeros to make 6. I can put my commas in, and I have 8,800,000. Try this next one on your own. This time I'm going to move my decimal point 4 spaces to the right. So I put down my 4, and my other 4 makes 1 space, and I add 3 zeros. And that gives us 44,000. We are now going to talk about square roots. A square root is the opposite of a number to the power of 2. For example, 7 squared, which is written like this, equals 49. And the square root of 49, written like this, equals 7. Now we will talk about perfect square roots. The square root of a perfect square is a whole number with no remainder. It is created by squaring any whole number. For example, 7 squared equals 7 times 7, which equals 49. The opposite of that, the square root of 49, equals 7. Other examples of perfect squares are the square root of 36, which equals 6, because 6 times 6 equals 36, and the square root of 4, which equals 2, because 2 times 2 equals 4. Find the square root of the following perfect squares. The square root of 9 equals 3, because 3 times 3 is 9. The square root of 25 equals 5. The square root of 64 equals 8. And the square root of 144 equals 12. I hope you enjoyed this video as much as I enjoyed creating it for you.